Now moving to vector subtraction. You can see that we can manipulate this subtraction and convert it into sum. But we will have to flip the D vector. Now we can simply add these two vectors together. Notice that the resultant vector magnitude will be less than the magnitude of the longer one. Adding or subtracting vectors of same direction is a simple and direct process. Look how visually we add these four vectors together. And we finally get the final vector of an amplitude of 3. Let's now move to the concept of vectors equilibrium. Vectors are said to be in an equilibrium state when they are opposite in direction and have the same amplitude. For instance, these two vectors are not in equilibrium, as one of them is 10, and the other is 6, which means there is a third vector x that need to be added to ensure the equilibrium. Working out some simple math, we can find out this vector x. After x is added to the game, the two final vectors will eliminate each other's and the final result will be 0. Let's now find the fourth vector x that will create the equilibrium state for the three given vectors. Let's first represent the three vectors on the coordinates plane. We then add the fourth vector x to them, so that the resultant will be 0. Doing the math, we can see that x is equivalent to the opposite vector sum of the three vectors. We will start by adding the blue and red vectors by employing the cosine rule and sine rule, as we learned before. Now we proceed with adding the third vector following the same concepts and techniques we learned. Now we can see that x vector is equal and opposite to the vector sum of the three vectors.